Alrighty, welcome back, boys and girls. It's your main math man, Mr. Shank, coming to you live from Walker Grant Middle School. Let me toss this calculator around. Anyways, it says for this box and whisker plots X ticket, numero dos, so that's that second one. Again, that's that sheet that is cut vertically in half. So now it has this. It says a baker recorded the number of batches of cookies they made on each of 7 days. So again, they have baked different number of cookies on each of those days. Alright, so it says they baked different number each day. Draw a box plot and label it to summarize your data. So it gives these values here. First thing you want to do, always list those values from, so we want to order least to greatest. And so again, I cross out as you use it. I'm going to say we have 5, we got 6, 7, 8, 10, 12, and 15. Again, you do this because if you look at our number line, it's going from least to greatest, and so this helps us organize our values before we do a box plot. Alright, so let's take and see what's going to be that median. Well, I should have equal amount of values on each side, and so we know that, okay, I can check off one at a time. I have an odd number of values, and so I'm left with one value in the middle. That's going to be our Q2, also known as our median. Alright, we have our min. Let me draw that carefully. Min. We have our max. Again, that's the largest value. Okay. So now, how do we find, again, our median of the lower half and the median of the upper half? So let's see. Well, again, it's saying that our value, or our set of data, is split into two halves. We have our lower half on the left and our upper half on the right. Since we have three numbers on each side, we're going to be able to just point out, hey, I know that 6 is going to be our Q1, also known as our lower quartile. So you can say this is Q1, and we know that 12 is going to be our Q3, also known as our upper quartile. Take those 5 numbers. So again, this is going to be called this. Again, we have those 5 numbers that I've boxed in. Again, the boxed in values is where we have our quartiles, and then we have our 2 extremes. This is our 5 number sum. I'm just saying we summarize the values into 5 important ones. Again, that's also called the 5 critical numbers. Either way you have it, you know it's correct. Alright, so let's see. I'm going to say that we can draw a vertical line above each of those numbers. So I'm going to do just like this. I'm going to have above 5. Again, I can kind of, not directly on the number line because I want to make sure I'm above it, but I just draw a vertical line above 5, like so. I take a vertical line above 6, above 8, just each of those critical numbers. Alright. I'm going to use the back of the calculator just to kind of give myself a nice straight edge so those lines are nice and even. Again, it doesn't have to be perfect, but you just want to make sure that you are pointing out those 5 numbers. Box in your quartile, so I can kind of start drawing our box like so. Kind of fill it in as well. It doesn't have to be perfect, but you want to at least give it some practice. And now what's the last thing? You need to make sure you have your whiskers, meaning the points from the quartiles to the extremes. Sorry, headphone users, but that's okay. We're done with that box plot. And it says, please answer questions on the back. So if you flip to the back, it reads this. It says, all right, only 25% of the days were above what number of batches of cookies. So I'm looking for 25% above. So if you think about it, it's asking about the top 25%. So let's see. If we, again, use our box plot, we know that, hey, each of these sections, again, this is 25%, this is 25%, this is 25%, this is 25%. Again, you're looking at this entire section. Even though it might look a little bit bigger, it's still saying that this is 25% of the data. So what would be our upper 25%? Well, that is this entire section here. So what value is that starting at? Well, a lot of people said this too, and I was real proud of them. They said, hey, I know that each of these sections is 25%, and 12 is our Q3, meaning above that is that 25%. So we could say, again, our Q3 is 12. So it's a 12 batches is what we're looking for. Again, always want to reference that graph that we have for ourselves. All right, so now it says the baker baked 20 cookies on the 8th day, and then redraws the box plot to include the additional data. You don't have to do that, but kind of picture in your head which statement comparing the new to the original is not true. Meaning this, 3 of these choices are true, meaning they did happen. So if we were to, let's say, look at our box plot or our set of values, and we threw another, let's actually use, let's say we put a 20 in here, what would happen? So we know our median, would our median increase? Yeah, it'd probably be about, let's see, it'd probably be about 9 actually. So our median would increase. So we can say this is true. Again, we're looking for something that is false. Did the upper extreme increase? Well, yeah, it was 15. Now it is 20. So we know this is true. The value of the interquartile range increased. Well, it would be what from before. Again, that's Q3, so 12 minus 6 is 6. And since, again, we're kind of shifting our values up a little bit since we are including that 20, we know that the interquartile range would also increase, so this is also true. Again, you can prove it by drawing out those values, but we know we can see it carefully. Very obviously, however, you can see that, hey, the lower extreme did not increase. And so we know that this is going to be false, which is what we are looking for. Again, you know that since if you were comparing those two box plots, you looked at the lower extreme, which is the min. And so if you look, you can say, all right, we know our min is 5. It would still be 5 in the new box plot. So again, make sure that you can see those values in there, be able to set it up for yourself, and draw those conclusions.